can learn from our video.
In this night of starry sky, my baby told me with a sigh, saying words that came across as a doubt. I reassured that every day my love is strong and gently placed in your heart. Is shown I can't live without. Every mountain, every sea can never stray a bird in me, no matter the state of space and time. Keep this close and keep this dear, not just today, but every year. You were made to be a focus in my mind. But if you don't want my love, and if you want something more.
Okay, so the experiment that we're going to do is trying to light up the light bulb. So we're going to try to do a single light bulb and a second light bulb. So our objective is to test whether the brightness decreases or increases when we increase the number of light bulbs in the series circuit.
Okay, so let's start the experiment. We need to start by connecting the red wires to the red wires in the EMF cable. Let's set up first. Okay, so now we already have the setup of the series circuit. Oh, sorry. Now let's see how bright the lamp with only one bulb. As you can see, it's very bright. Now let's try when we use two bulbs. Okay, so now we already have two bulbs. Let's try to turn it on. Oh, let's see. You see, the bulb decreases. The light in the bulb decreases. So we can define
That the brightness decreases when we add more number of lamps in a series circuit.
Okay, thank you very much. So now I'm going to explain about the resistor in a series and the resistor in a parallel circuit. So here we have two resistors, and the total resistance in the series will be equivalent to the sum of the two individual resistors, which is resistor 1 and resistor 2. And the formula is R equal R1 plus R2. Next. Now we have the resistor in the parallel circuit. For the two identical resistors, the combined resistance will be equivalent to half value of each of them. And the total combined resistance will be less than the smallest resistor.
Okay, so now we're gonna try to solve a problem. So we have a problem here. So we're given a kind of circuit like this, and we're given the values of cell 1, cell 2, R1, and R2. So cell 1 has an EMF of 3 volts, cell 2 has an EMF of 1.5 volts, and resistor 1 has a resistance of 2 ohms, and resistor 2 has a resistance of 4 ohms. So to solve this, we need to calculate the current. So that's the problem, and we're trying to find the current. So to do this, we have to use the Kirchhoff's second law, which is the conservation of energy, and we have to use its formula. So finally, we have to minus each of the cell 1 and cell 2. So cell 1 is 3 volts minus the cell 2, which is 1.5 volts, which is 1.5 volts. And now this one, so basically this is the E. So now it's like this, equals to I and times by R1, which is 2 ohms, and plus and times second R, which is 4. Now you get 2i's plus 4i, and now you combine it, 6i, and now you just move the 6 towards here. So two ranges become like this, and the answer should be 0.25 ampere. So now I'm gonna be explaining and give a brief introduction of what is DC circuits about and what is in the topic DC circuits. So the long version of DC circuit is direct current circuit, which is an electric circuit where the electric current flows in only one direction. So these are some of the symbols of electronic circuits. So you can see all the different kinds of symbols and drawings for every each different kinds of components. So these are some of the common circuit components. So now I'm going to be explaining each of the function of some of the common circuit components. So first is wire, which carries electricity or other signals, and second is switch, turn circuit off or on, and third is thermistor, temperature dependent resistors, which changes resistance with changes in temperature, and next is LDR, which the long term is light dependent resistor, where the resistance changes depending on the light intensity. And next is battery, which is the power source that converts chemical energy into electrical energy. And next is diode, facilitate the flow of electric currents in one direction. And seven is LED, which the long term is light emitting diode, which emits light when an electrical current flows through it. And next is resistor, which regulates the flow of electrical current in an electronic circuit. And next is variable resistor, which allows for the adjustment of resistance in a circuit. So next, I'm going to be explaining about EMF, which is also known as electromotive force. So EMF is the energy provided by a source like a battery or generator per unit electric charge. And it has the formula, which is EMF equals to work done or energy transferred per charge. So the unit for EMF is volt, which has the symbol V. Next is PT, which the long term is potential difference. So the definition is difference of electrical potential between 2 points, and it has the formula V equals to I times R, where I is the current, V is the potential difference, and R is the resistance. And it has the same unit as EMF, which is volt, which has the symbol V. Now, internal resistance and terminal potential difference. So, internal resistance is the network configuration or an electrical circuit that uses a switch. And terminal potential difference is the potential difference between terminals of a cell or power supply when current is being delivered. And they both have a combined formula, which is E equals to V capital R plus V small letter r. So the small letter r represents the internal resistance, while the big letter R represents the terminal potential difference, and E represents the EMF. So next, there are two kinds of laws. So far, the first one is Kirchhoff's first law, which is the conservation of charge, where it states that sum of currents entering a junction in a circuit is always equal to the sum of currents leaving the junction. So the second law is Kirchhoff's second law, which is the conservation of energy, where the sum of the electromotive force in a closed circuit is equal to the sum of the potential differences. So what is a potential divider? So potential divider is a simple circuit that uses resistors in a series to reduce or divide a voltage, producing an output voltage that is a fraction of the input voltage. And something related to potential divider is the potentiometer. So it is a three-terminal variable resistor that acts as a potential divider, allowing for a continuously variable output voltage by adjusting a sliding or rotating contact.